More and more AHJs are asking for load calcs, even for quick EV charger retrofits. Figuring out whether you need a panel upgrade might mean digging through the NEC, second-guessing demand factors, or hunting down old spreadsheets from past jobs. And even once you've done the math, you still need to present it in a clean, professional way, something an inspector can easily review and approve without extra rounds of back and forth.
We've seen thousands of calculations from electricians and inspectors across the US. The good news is, most AHJs are looking for the same few things. That said, requirements can vary by region, so as a responsible license holder, be sure to check in with your local AHJ to confirm that your work meets all local requirements.
In this video, we'll show you how to run a proper load calculation for a retrofit EV charger install in just a few minutes. We'll be using the optional method from NEC 220 Part 4 and generating a permit-ready PDF with our Kopperfield Load Calculator. Honestly, once you know the steps, it's way faster than you'd think.
So let's say you're on a job site with a homeowner who just got a new electric vehicle.
So they want to install a level 2 EV charger, and the local AHJ is asking for that load calc to make sure that their 100 amp panel can safely handle the additional load.
As an electrician, you've likely noticed a surge in electrical vehicle ownership. EV chargers are becoming popular in homes across the country. But when it comes to getting a permit and passing inspections, electricians have to make sure to properly account for EV chargers in their load calculations.
Homeowners always want cost savings, but it's up to you to make sure the installation is safe and compliant. So let's walk through how to get a load calc done the right way, helping you save time and win more work. Before we get into the numbers, let's talk about EV chargers and how to handle them in load calcs. This is an area that often causes confusion.
Almost all AHJs expect that EV charger loads are called out separately, not lumped in with general loads, and not reduced by the 40% load factor. We've heard time and time again that most inspectors won't go for that.
Secondly, we've heard that most AHJs want to see the EV chargers taken at 125% of the rated current because it runs for more than 3 hours continuously and it qualifies as a continuous load under Article 100. And this is what most electricians are choosing to do on their calcs.
Finally, if your AHJ is enforcing the 2023 NEC, Article 220.57 specifies that EV-SE load shall be calculated at a minimum of 7,200 VA for each EV charger, or 100% of its nameplate rating, whichever is larger. That's a change from how some folks are used to doing it. If you're not sure how your local AHJ wants it handled, it's always a good idea to double check before submitting. Now let's get into the load calculation.
The NEC offers a choice of doing the load calc with the standard method or optional method, described in 220.82 for new dwellings and 220.83 for existing dwellings. The optional method is a bit faster and it's much more popular. That's what we're going to use today.
All right, so let's walk through the job. The customer has a 100 amp service, and the big question is, can it handle a new 32 amp EV charger?
The NEC wants you to handle the general lighting and general use receptacle loads. This is calculated at 3 volt amps per square foot. This homeowner lives in San Francisco, so I'll plug in their address, and our calculator automatically pulls in the square footage. In this case, it's just over 2,600 square feet. So 3 times the 2,600 square feet is around 7,800 VA, and it looks like the calculator has got that accurately. Now we add in the small appliance circuits. The NEC has a minimum of 2 of these at 1,500 VA as well as the laundry circuit. Some homes might have more than the minimum, so factor it in if that's the case.
Next, we can add in heating and cooling. The NEC says that when you have both a heating and a cooling system, you only need to include the larger of the 2 loads, not both. If you have equipment that is involved in both the heating and cooling scenarios, like a heat pump, put it in both the heating load and the cooling load section, and the software will automatically pick the larger load. In this case, the customer has a gas furnace with a big blower, which is rated at 10 amps. At 120 volts and at 10 amps, this is 1200 VA.
Finally, we'll list out our other loads. According to 220.83, these are appliances that are fastened in place, ranges, wall-mounted ovens, and counter-mounted cooking units, clothes dryers that are not connected to the laundry branch circuit, and water heaters.
That's right, we don't need to include every single appliance in the house. We sometimes see load calcs with tons of small plug-in devices, but that actually slows things down and makes the results less accurate. Most of those small loads are already covered by your general lighting and receptacle allowances.
To complete this section, electricians will usually look at the electrical panel on site or grab a photo of the panel and do it in the office. In this case, we've got a photo of the panel, so we'll upload it here and let AI jumpstart the calculation for us. This house is pretty standard, and it has a couple of bath fans, dishwasher at 900 watts, disposal 300 watts, dryer at 5 1000 watts. Garage, standard. Microwave, pretty standard. And now this home also has a gas water heater that doesn't use electricity and a plug-in gas range at 600 watts. And this wasn't on the panel label, which happens sometimes. It's always a good idea to do a quick walkthrough when you're on site to check for larger loads like HVAC, water heaters, and cooking appliances. If you're not sure, ask the homeowner.
Now it's time to add in that new EV charger. This EV charger is rated to charge at 32 amps and 40 volts. Since this AHJ expects to see this at 125%, we select 9,600 VA.
To finish off the load calculation, we now get to apply a load reduction from 220.83. It can be tricky since the code requires that the first 10,000 VA are taken at 100% for new construction, but only the first 8,000 VA at 100% for retrofits like this one. Then you get to apply the 40% beyond that. We've seen this trip people up. Fortunately, the calculator handles this for you automatically based on the dwelling condition that you select.
It's extremely rare, but if you do need to adjust the percentage or adjustment, you can customize it to meet your local AHJ requirements.
Now, with everything accounted for, our total adjusted load comes out to 99 amp.
The 100 amp panel is good to go after all. No need to upgrade.
Nice. The customer is going to like that. And you've got a clean and professional PDF ready to submit for a fast approval from your AHJ.
So next time you're on site, snap a panel photo or use the Kopperfield mobile app, run a quick calc, and move forward with confidence. You're saving time, showing up sharp, and protecting your bottom line.
You can try our load calculator for free at kopperfield.com. And if you found this helpful, hit like and subscribe for more tips on electrical design and permitting.